Now we've learned how to factorize quadratics using the sum and product method, let's take a look at what we might need to do beforehand to be able to use that same method. Now last time I mentioned that the sum and product strategy can be used to factorize trinomials when this a value is equal to 1. Now it's not always equal to 1, but sometimes we can still use the sum and product method if we look to remove highest common factors first. So let me give you an example. Let's say I had the problem 2x squared, subtract 8x, subtract 24. Now you'll immediately notice here that our a value is equal to 2, so it's no longer equal to 1, which means in the form that it currently is in, we can't use the sum and product strategy to effectively factorize this trinomial. But one step that we should always do, it doesn't matter what sort of factorizing you're doing, is we should always check to see if there's a highest common factor and factorize by highest common factor first, because it makes our life a lot easier as we move along. So in this case, I can see that each of our terms here has a common factor of 2. So if I factorize this whole trinomial by 2, it'll be equal to, so 2x squared divided by 2 will be x squared. Negative 8x divided by 2 will be negative 4x. And negative 24 divided by 2 will be negative 12. And now what you'll notice here is I've got this quadratic trinomial inside of brackets. And if I ignored sort of this 2 at the front now, because I've got it inside brackets, the coefficient of my x squared now, so my a value, is equal to 1. So what I can do is I can now use the sum and product method to factorize this trinomial that I've got in brackets. So here, I'm looking for a sum of my b value. Now my b value is negative 4 here. And a product of my constant value, which is negative 12. So when I look at this, I've got a product that's negative. Now, to multiply two numbers together and for it to be negative, that means one of them will have to be positive, one of them will have to be negative. And I notice that my sum is also negative, so the larger of those two numbers will have to be negative. And that'll help me as I explore what factors of negative 12 will add together to be negative 4. So, factors of negative 12. Let's start at 12. Keep in mind, my biggest one's going to be negative, so negative 12 and 1. When I add these two together, negative 12 plus 1 will be negative 11. So that combination doesn't work. What about negative 6 and 2? Well, negative 6 plus 2, well, that'll be negative 4. And our sum is negative 4. So this combination appears to work. So when we factorize this now, we have to keep our common factor, so that we've removed from the trinomial, the original one, of 2 at the front. We open up our brackets now, like this, with our two x terms at the front, as we did before in the previous video. And we put our two numbers here now as our second terms in each bracket. Doesn't matter whether you put the 2 first, then the negative 6, but the negative does belong to the 6. So we'll have subtract 6 here, and plus 2 here. Now, as with before, we can check to see whether this here is in fact equivalent to the expanded form that we started with. So let's check this by expanding it out. I'm going to rewrite it to begin with. Now, to expand this, I'll first expand the quadratic that I've got here, so these two brackets. So this will be equal to 2, open up a bracket, x times my x will be x squared. X times my positive 2 will be plus 2x. Negative 6 times my x will be subtract 6x. And negative 6 times positive 2 will be subtract 12. And now I'll simplify this as I go, so I'll collect the like terms. So these two are my like terms here. So this is equal to 2, open up my bracket, my x squared, 2x, take 6x will be negative 4x, and then subtract 12 here. And you might notice that we've actually arrived back to this step in here. So we've got the equivalent of this. Let's just make sure that it expands out to equate to my expanded form. So this will now be 2 times my x squared, which will be 2x squared, 2 times my negative 4x, which will be negative 8x, and 2 multiplied by negative 12, which will be negative 24. Which, as you can see, is equivalent to my expanded form that I began with. So this factorised form is equivalent to this expanded form. So I've factorised this correctly. But let's take a look at just one more example. Let's say I had 5x squared, subtract 45x, and then add 100. So my first step is to check to see whether I've got a highest common factor here, because I can't just use the sum product rule because my a value is not equal to 1. So in this case, I can see that all three terms have a common factor of 5. So let's factorise this with a common factor of 5, which will leave me with just x squared. Negative 45x divided by 5 is negative 9x. Then 100 divided by 5 will be plus 20. And now I've got a quadratic inside the brackets where my a is equal to 1. So now I can use the sum and product. So what I'm looking for is a sum of the coefficient of x, which is negative 9. So a sum of negative 9. And a product of my constant terms. So a product of 20. So I'm looking here and I'm thinking to myself, my product is positive. So that means I'm going to have to either multiply two positives together to equal this, or two negatives together. But my sum is negative. And if I'm adding two positives together, I'm never going to equal a negative value. So it means that my product, my two numbers I'm looking for, have to be two negatives, because when I add two negatives together, they'll equal a negative. So now let's look at the factors of 20. So if I start at 20 and 1, but they're two negatives, well, negative 20 take 1 will be negative 21. So that won't work. So how about 10? So negative 10 and 2. Well, negative 10, it will be negative 2. So negative 10 subtract 2 will be negative 12. So that one won't work. So I think about it a bit more. What if I looked at a factor of 5? So negative 5, which would be negative 4. So negative 5 subtract 4, that will equal negative 9. So this appears to be the correct combination here. And what I do with this is I keep my common factor at the front, I open up a bracket, and it'll be x subtract 5 in this case, and then x subtract 4. And that is now factorised into the linear factors. But let's just check this to make sure that we've got it correct by just expanding it back out. So when I multiply this out, let's multiply the two brackets together first. So using FOIL, so x times x will be x squared. X times negative 4 will be subtract 4x. Negative 5 times x will be subtract 5x. And negative 5 multiplied by negative 4 will be positive 20. So now let's collect the like terms here. So this will be x squared. These two are like terms, so negative 4 take 5 will be negative 9x. And then add my 20 at the end. And then I'll need to multiply this 5 out with each term. So 5 times x squared will be 5x squared. 5 times negative 9x will be negative 45x. And then 5 times this positive 20 will be plus 100. And if we take a look at this, that is equivalent to what we began with up here. So it means that we've factorised this correctly. So what's really important here is, doesn't matter what sort of factorising you're doing and what sort of strategy that you're using, we always look to factorise by highest common factor as our very first step. And if we can factorise by highest common factor, and it leaves us with a quadratic trinomial where our a is equal to 1, we can still use our sum and product sort of strategy to find our two linear factors for our trinomial.